Hey! Where's this thing? Calibrate, 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 calibrate. Hooray! Now if only this thing would work. Yeah. So, in this problem, uniform rod AB of length 2r rests inside a hemispherical bowl of radius r, as shown. Determine the angle theta corresponding to equilibrium. Alright, so if you were to take if you were to leave your mixing spoon in your mixing bowl and you're making cookie dough, it's not going to stay up like that unless you got a lot of cookie dough down here. It's going to tip over to make this. So that's why I mean, what angle does it stop? Well, it's going to stop at the angle where you reach equilibrium. And whenever you see the word equilibrium, you need to start with the three-body diagram. That's just back to life. So let's do coordinate systems first. We're looking for that angle theta, so we should probably do it. Standard issue y, x. And we got gravity, except that it doesn't appear to have weight. Weird. So, well, no, because if it's weightless, why did it fall down like that? So, we're just going to call this weight. And we have 2 points of contact. We have a point of contact here. And we have a point of contact. And that. Okay. Here, perpendicular to this thing. No. And here. That and that. Perpendicular. Normal forces are perpendicular to the surface they're acting from. So, 3 forces. This should be fun. Okay, so maybe we shouldn't have done that before. Oh well. This is theta. I don't know what theta is, but that angle is definitely theta. And trigonometry. This is going to be theta. And look, this is off. Okay. I think this is pointing up. What do you guys think? Yeah, it looks like it is. Which means the B is also pointing up. But that's how it works. On the other hand, it is a curved surface.
So, pushing x, that means that way.
Well, I mean, I look at B and I see that. So, there has to be another x component. Wait, so this, Yeah, it has to be going like this. But I'm not sure geometrically what angle that makes.
So I think like heading over and going in the Y direction.
No, because then the bull is pushing it in the X direction. You have to have something counteracting that force. So I think doesn't make any sense. So, we have a bowl like this, and we have this point here. And we want to know angle theta. It's going to be same as this angle theta, which is gamma. So maybe we're supposed to assume it's going to end up being that theta. Look at this and this. Okay, this over this, and this is like this. This is theta. And alright, just for now we're going to call this angle gamma. It does not look like a gamma. Yeah. Gamma. Okay. And we're going to call this A. And we're going to call this B. Well, let's do components first. B in X direction is going to equal negative B times cosine of, no, not cosine, sine theta. B in the Y direction is going to equal to B sine theta, cosine theta A in the X direction is equal to A times, I'm going to move this so that it's, we're going to find this angle as gamma. So that this becomes A sine gamma, and we're going to find A sub Y as a cosine gamma. And then this is nice because we do. So the forces in the X direction is equal to 0. So A sine gamma. Wait, this doesn't work out. Oh well. Minus B sine theta equals 0. And then we have sum of forces. Y is equal to 0. So we know that E cosine theta plus A cosine gamma equals 20. So, right there, we're going to assume the weight is known. We have 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4. equations. We need 2 more equations. It's either going to be relating gamma to theta. I'm pretty sure it's either going to be theta or 90 minus theta. But I'm not sure. I'll prove it. You didn't post them yet. No, not for 8. Yeah. Ay. It's got something to do with circles. I don't like circles. So perpendicular to the edge of this, it's going to be tangent, so it's going to be pointing towards the center. I mean, that's just facts. But this isn't pointed to the center unless theta is equal. It's not going to point through the center, because if it points to the center, it's not leaning on B. So, does anyone know how to find one of those lines? So, yeah, it's geometry. I hate geometry. So, perpendicular to that, and it's going to be, this angle is gamma, and oh dear. I think it's gamma, and theta, okay. These two are the same line. So, both theta. So, in this case, theta plus 90 plus alpha equals 80. Alpha equals 90 minus theta. So we call this one alpha. We call this one omega. Alpha plus omega equals 80. Omega equals 90 plus theta. Gamma plus theta plus omega equals 180. Gamma plus theta equals 90 minus theta. That angle theta and this angle. Why did it stop? I'm going to call it zeta. Beta plus theta equals zeta. Zeta equals, those are the same, so zeta is equal to gamma. Those are the same length. So gamma plus gamma minus theta equals 90 minus theta. 2 gamma equals 90. Gamma equals 45 degrees. Oh, well, duh. Oh, I see why I did it wrong. Nope, that didn't work. I did that wrong.
Okay. Some people I saw working on moments and stuff, but I don't know if they actually never do it or not.
Yeah, let's just go ahead and do the moments. Okay, moments. Sum of the moments about, ooh, that's interesting. This is a nasty problem. Let's Google it. Like 4.84, right? Yep. They don't go through and do the problem. Okay. Not these guys. I want you to let them go back to my system. Nope. Most of these places want me to download it. So what I'm getting from this is that I don't know enough geometry. Great. Anyway, interesting to note that we have this overshoot here.
Yeah, like we're still using overshoot. Make up like a counter, but
Yeah.
that's where
Yeah, I think we should do a different problem. I got no idea what this is.
I could have been setting a last problem with a good one.
That's problem. Second honest problem. Okay. Okay. 2.4 meter boom, served by a ball and socket joint at C. Ball and socket joint provide restrictions in 3 dimensions, but do not restrain movement. So the reaction is going to be an X force, Y force, and Z force by the moment. Determine the tension in the cage cable and the reaction at C. Okay. You. So let's do a free body diagram of this blue mic. No, not blue mic. So we got weight. And we got the 2 tensions. So we're going to call this PD and PD. And we have these reaction forces, which are R, Y, R, X, and Alright, so I'm not, my X's and Y's look a lot alike, so. That's what we're looking for, and we're also looking for these 2. So, I look at this, and I want to start drawing vectors. Not much, but I want to start labeling vectors. So, when I do vectors, I like to first do a point table. So, we have 5 points, A, B, C, D, E, and 3 dimensions, X, Y, Z, and you just list their properties. So, this is 0, 0, 2.4, 0, 0, 1.2, 0, 0, 0. C is negative 0.8, 0.6, 0, this is 0.8, 1.2, 0. And then we can start making vectors. So the vector for from A to D is negative 0.8, 0.6, negative 2.4. And it's easy to do this with the points table because you can just say, okay, this minus this, this minus this, this minus this. And that's not right. That's the vector from D to A, not A to D. Okay. From A to D should be, no, wait, that wasn't it. This whole arrangement of X, Y, Z. See, they have to do Z, Y, X, and I like to do Z, Y, X. So, I get confused by these diagrams sometimes when I'm not paying close enough attention. So, and we also need AE equals 0.8, 1.2, negative 2.4. Okay, and when you're doing these, you just want to take a moment to do what we in the business call a reality check. So, you just look at this picture, and direction you go. If I started A and I start walking towards the other point, what directions am I going? And you're like, okay, I go back in the X direction. Okay, X is negative. I go back in the Z direction, Z is negative, but I also go up. So Y is positive. And so, yeah, AD is correct. If you do that for AE, you go, I go out, I go up, and I go back. So positive, positive, negative. It works, great. And then, so we have those, we need to make those unit vectors. So then, TD is equal to TD times calculate your calculator. We take this, we go square root of 0.8 squared plus 0.6 squared plus 2.4 squared equals 2.6. And we do out of that, we get 4 out of 13, 3 out of 13, and 12 out of 13. And then we do the same for TE. And we got 0.8 squared, 1.2 squared, 4 squared. The root of that is 2.8. And we have 2/7, 3/7, 6/7. All right, we can erase this now. So let's give W a vector as well. 0, -1, 0. You understand how I came up with that vector? Yeah. Because it's pointed down in the Y direction. Yeah, because this part, the vector part, has to be a unit vector, which means the magnitude has to equal 1. So if you have 2 zeros and 1 1, you just put that just 1. We know it's in one direction. Not the band. I don't know if it can sing that well. And we also know that it's pointed downward. So voila. And we might as well just get some R's ready. Our CD equals 142 times 0, 0, 1. Our CA equals 2.4 times 0, 0, 1. Okay, let's do some Newton. Need some of the forces in the X direction. We're going to equal 0. So what we have there is 4/13. It should be negative 4/13 TV equals 0. So what we get is that TE equals, that's going to be 7 times, just 2/7 TE equals 4/13 TD. When cancel. So yeah, 2 times, so that was 2. 7 out of 13 is 14 out of 13 TD. And then we do the sum of the forces in the y is 0, so I forgot the R. Damn it. Okay, that's better. Okay, sum of the forces in the x equals 0. We have -4/13 TD plus 2/7 TE equals, yes, our x equals 0. And then we have sum of the forces in the y is 0. We have 3 out of 13 T sub D plus 3 out of 7 T sub E minus the weight plus R sub Y equals 0. And then we have sum of the forces in the Z is equal to 0. So we have 13 TD should be negative minus 6/7 TE plus R sub Z equals 0. Well, how many equations we have? We have 3 equations. How many unknowns? 1, 2, 3, 4, 5. 5 unknowns. 1, 2, 3, 4, 5. Those are our unknowns. 2 more equations. The sum of the moments about the origin, which is point C, is going to equal 0. And so we have 0 is going to equal RCB crossed with the weight plus RCA crossed with TD plus RCB crossed with TE. That's one more equation. Fluid this equation. I got that wrong. You're supposed to do the sum of the moments about the x and the y and the z axis. Oops.
Why do they want you to apply this on the x?
I'm not sure. Oh, wait, no, that's not it. Wait. says section 4.1, it explains it. Yep. Because then you can have 6 equations, and the more equations you have, the better you're off. So, this is taking up a lot of space. Okay. I'm tired. Some in a moment, but the x-axis is
the stuff that you had previously.
yeah. Oh. I haven't had to do this in the longest time. Oh, great, great, great. Oh, wait, yeah, that gives us a vector. Yeah, we're good. Okay, some limit at C is R CD crossed with the weight vector plus, you know, everything I said back here. RCA crossed with D plus RCA crossed with G into D. Alright, so these are cross products, which means they give vectors. And since we have, this will give us 3 equations. Does that make sense? Great, that's how you solve it. The rest is just algebra. Algebra! That was annoying. When all those fail, Google the problem. You'll usually come up with some solution.
I found a lot of solutions just with different units. That's a lot of
Well, if you use your brain when looking at them, you'll understand what they did, and then you can reapply it here. It just takes thinking. Oh dear. So, yeah, so whenever you do the sum of a point, just remember that it is, in fact, a cross product in the 3 dimensions. This works in the 3 dimensions. In the 2 dimensions, doesn't. Yeah. Well, the point is that when you have 2 dimensions, you only have one possible axis of rotation, which is the z-axis, if this is y and x. You know, if you try to rotate about the x-axis, you start going with the z point. So you can't, or not a Z plane, you start having a Z component. So the only rotation you can possibly do and stay in this plane is in the Z-axis. But when you do 3 dimensions, you can do all sorts of rotation. And that means you have 6 axes to rotate. Axes to rotate them out. So this cross-body kit is only going to work in 3D. So in 3D, the sum of the forces equals 0 and the sum of the moments equals 0 gives 6 equations. In 2D, it gives 4 equations. So, anything else? I guess we can try to take another look at that other equation, that other problem. Go back and look at it.
I don't think they're good. I think they're not like
Like that? You have?
I think we have one similar, but I think it has to go we have a lot of really
Mm-hmm. Well, it's really just a statics problem. It's just involving geometry that I can't do at the moment. So, that's the only thing is, like, I'm just not that good at geometry originally. This problem requires a lot of understanding of how to circle, which is annoying me. Who's gonna be people? I don't know.